All right, guys, let's take a look at how to use technology to come up with the equation if you have some data. Like this is an example here using Desmos, and I'm going to do it also on my graphing calculator. But let's say this table of data, this is about the number of insects over a certain time period or whatever. So Y is going to be the number of insects, X could be the number of days or weeks or whatever. So what I did first, I would just go to add here and add a table so that we can add this data in. And then you can always just, it'll plot it. I just turned it off so we wouldn't focus on that initially. But basically, this is what the data looks like. Okay, and we can also tell just from looking at the data how the values increase first and then decrease. That a linear function is not going to be the way to go. We're going to want to go with some sort of quadratic function so it can have that up and down type behavior going on. Okay, so since we do believe that it is a quadratic equation, what I want to do is actually type in the Desmos here. Here's how you're going to do it. Standard form or general form for a quadratic is ax squared plus bx plus c. So what we're going to do, since we want to use these data points, okay, we want to use the y1 and the x1, we're going to tell Desmos to use those by typing y1, and then there's a little symbol. It's above the, it's next to the 1 on the very top left, called a tilde. It looks like a little single squiggly. You have to find that. And then what we're going to do is type in the format that we want our equation to look like. So we want to have it as a times x, and I'm pressing 1. And then I'm going to go squared. Okay? So it's ax squared plus bx. And anytime I put an x, I'm putting a 1 again because that's telling Desmos to use these x values. And then I'm going to put a plus c on the end. And what it's going to do, okay, it is giving me the a, the b, and the c value of what's called the best fit, in this case, a curve. Okay, it's not linear, but this is a parabola. And since we put those ones in there, and since I use the tilde symbol, that's the key for Desmos to do what's called this process of regression. Okay, it's using all of the data points and it's finding the single best equation that it can. And basically what it's doing is it is taking all these distances from the point to the line, okay, which is called the residual, whatever that difference is. Okay, you can learn more of that in statistics. But it is minimizing those values basically to simplify it a little bit. And it's giving us the best possible equation. Okay, so we can see the A, the B, and the C. That would be what's called the best fit equation. We could use that then if we wanted to find the vertex, okay, using the negative b over 2a, or a cool feature with Desmos, if you just click on it, it will give you that point. So this point was not one of the points in the table, but it's actually like the maximum value, excuse me, based on what the equation is, okay? So that's how you do this in Desmos. Now to do the same thing in the graphing calculator, what you're going to do, you're going to go into Stat, and then enter on edit here. And I typed the same data in just to save some time. The same table, list 1 is the x's, list 2 is the y's. And to tell the calculator to find the equation, you go back to stat, and then you go over to calculate, and there's all these different regressions. Okay, and again, we were focusing on quadratic based on this shape, just based on how the data looked. So I'm going to do a quadratic regression, and then it's just going to default to list 1 and list 2. That should be where your x and y values were stored originally. And when you go down to calculate here, it's going to give you the same values that we got when we used Desmos. It gives you the A, the B, and the C. Okay, so it's using technology, and again, it's what it's doing is finding this best fit equation. It's not a perfect fit, okay, as we saw in the Desmos graph. Not all of the points went through it, right? But it's doing the best that it can. Okay, and that is the process of regression.